Okay, I'm going to take this a little differently today. I don't know what the hell I'm trying to say. So I haven't made a video on reinforcement learning in a while, and that's because every time I started a project, I found myself not really getting the kind of results I want. And in other videos, I discussed what those difficulties were, namely that when you create an agent in a reinforcement learning environment, typically the agent works best in a static, non-moving sort of gym or environment, meaning that if I have a chessboard and I'm trying to teach my agent how to play chess, I can train the agent over 1 million games, 10 million games, 300 million games if I want. But with investment and trading, you've really only got a short window of data. And it's a time series stochastic moving line graph, essentially, that the agent is trying to understand. And you can either train on like 10 years of data for a single stock or multiple stocks, but each one of those stocks is kind of individual. And so it depends on what stock you choose, it depends on what portfolio you choose. And then in the end, you can either train it to a point where the policies don't converge on a really productive strategy, and so you don't get the results you want, or you overtrain on a specific stock or set of stocks and you've overfitted, and so when you introduce new data, it doesn't adjust well to that either. And this problem really plagued me for a long time, and I started improving it, building my own sort of spin-off of finrl. And life things happened, and so I didn't really pick up on it again until recently with the improvements of AI. I've been able to be a family man, be a career guy, and also code on the side. And I've finally gotten to a point where I've got a project that I think handles this issue directly. So it's essentially an infinite data generator that tries to simulate the market as best as possible. And it blossomed into something really cool, and I want to share that with you today. And then in future videos, I hope to go through the entire sort of pipeline from beginning to end and show you how you can use it and what kind of cool training that you can do with it. Let me close out my screen here and share my repo. Oops, oopsies. We're already to a bad start. Okay, and let's make this a little bigger. So here we have Spectral and Core V1 is the repo name. I should probably clean that up, but this is my specialized research environment designed for testing reinforcement learning agents on high dimensional financial data sets. And like I said, this is just essentially a engine that will create realistic market conditions for your agent to train on. And so you're not having agents memorize historical price sequences, but you're teaching it to generalize, things that happen in the market. And so it can identify the regimes and trade accordingly. And what started out as just a simple, can I create something that creates a lot of unique momentum and mean reversion type market conditions, grew, and it now has other processes that make it more realistic. For instance, we've introduced student fat tails, meaning that in the market, you don't have a perfect distribution of prices across time. So without the fat tails, the agent would not assume that prices could jump sort of randomly or sporadically, really high or really low. And we know that's not true. And so introducing this into the engine allows the agent to learn risk management. The other sort of related topic on that is the idea of volatility clustering. This is the idea that turbulent periods are followed by turbulent periods and calm periods are followed by calm periods. And this allows, the agent to also learn risk management, but also makes the engine provide opportunities for the agent to do position sizing, because as the volatility changes throughout the experience of the time or in the period, the agent can learn to position bigger or smaller based on identifying whether or not the volatility clustering regime is happening. And that also helps it helps it have to separate it out against Merton jump diffusion idea, where you'll have flash crashes or you'll have an earnings period where you'll see, we've all seen stocks that outperform their earnings call, and so it jumps really high, or it underperforms and then it drops really low and then readjusts. And so we've actually introduced that into our engine that you can customize and slide based on your certain parameters that you want to train for. And then of course we have the regime instances where we have momentum and mean reversion, so it can learn timing in its strategy, and the Markov regime switching. So you could say, I want not just a momentum period, but I want a momentum period in a bull market, or I want a mean reversion in a bull market, or momentum in a bear market, or something that goes all over the place. So we see a momentum and a mean reversion in the same bull market, et cetera, et cetera. So you can have different underlying market conditions, and you can swap them out. And they're unique each time to each period, so that the training agent will see unique instances of these regimes happening across your training period. So you could have 1 million momentum instances, or you could have 1 million mean reversion instances in a bear market, and you can set those sliders so that your agent gets really good at identifying those regimes. And vice versa, you can make it very chaotic. You could have it train on momentum, a period where there's a momentum and a mean reversion instance regime in the same training period. Cool. It's pretty easy to get started. You can literally get started with these 4 or 5 lines of code here, and I'll get into this deeper. But the estimate params, so there are tons of parameters that we have. Kind of going on a tangent here, so let's just be careful I don't go too crazy. But we have a lot of different parameters that we can set in our environment. We have all these guys here, right? And so setting these up in the environment one by one can be really difficult, and you don't know whether or not you are actually setting your environment variables to be realistic. And so I've created a little function where you can pass through an equity like NVIDIA, and you give it the period, and then it will extract the parameters of the market that you want to fit with the engine. So in this instance, I'm basically saying extract the Garch and the jump diffusion and the fat tails and the Markov switching on NVIDIA for the last 3 years, and basically create where your number of steps is 252 trading days, and you start with $50,000, and you can trade up to 20, and you can hold 200 shares at any given time of NVIDIA. And it will just spit out essentially 500,000 different NVIDIA paths over that year, and so I think that's really the value that this brings to our training. It does work for other securities too. You can make a portfolio, so you can track Apple, Microsoft, NVIDIA, JP Morgan, and then the S&P 500 index, extract all those parameters, put it into your environment, and start trading as much as you want. You could set this total time steps to 500 million if you want, and it will basically learn the market conditions for this 3-year period across these stocks until it finds a great strategy. You can also do crypto. So we do fractional positioning. If you'd want to buy a portion of Bitcoin or Ethereum, you can totally do that as well. And it works on the same params. You just pass in the BTC USD for a 3-year period, and you'll get the same sort of market conditions that you need to train on that as well. It's not just an environment. I also wrote a feature extractor, some diagnostics callbacks, and an entropy coefficient callback to help with your training. It also does, and I'll get into that a little bit more later. You can also do parallel training. So I typically spin up 8 different environments and let them train together, and that really improves the training lifetime, or just the time it takes to train 5 million times, right? So that's also an option as well. Then we just have, an overview of the API. We've got some tutorials. I've actually got more than 7 here, but it goes from basically the value proposition of the repo, and then it starts taking you through more and more advanced, pipeline from beginning to end. And we've got some highlights here. Sell only transaction fees. So you're able to set friction at the time of trading because realistically you have transaction costs and you have commissions. You have spread costs. So if the bid is one number and you actually sell at a different number, that's all taken into account as well. Forced terminal liquidation, you can turn this on or off, but I'm assuming that all positions need to get sold at the end of the year. This prevents the agent from holding forever because although that might be the best strategy, that's not exactly the thing that we want our agent to learn to do. We want it to find alpha within the market that exceeds the buy and hold forever. And that kind of follows nicely into the alpha relative reward structure in itself. So most of the time, your reward structure and other reinforcement learning toolkits is such that you have a basic P&L statement and you're just trying to optimize for profit and loss. But in my environment here, what you're actually doing is the agent gets rewarded for any action it takes that improves the returns from a benchmark. So the benchmark is just buy and hold for the period of the year, and you get rewarded when you can actually outperform it, which is exactly what we're trying to achieve anyway. So in the future, I might make it so that we can have different types of rewards. So not just this benchmark reward, because people might want to train for different outcomes that they're looking for. So I might make it a modular reward setup in the future, but just for now, it's measuring against the benchmark of buy and hold. We also allow it to see how far it is along in that year. So, earlier in the year, it might try to be really risk forward and trying to take big risks because it knows it has more time in the year to, make up for losses. And then as it gets closer to the end of the year, it will see that it needs to lock in its actual realized gain, right? So we allow it to see its deferred liability and episode clock. And I think what the most important aspect of the environment and sort of the main value add is that each episode is a different momentum reversion character of the market. So you're not having the agent learn a specific momentum outline or specific mean reversion line graph. You're actually having it be able to identify that the regime exists and be able for it to generalize across any stock or equity that it sees. Excuse me. This is just the project structure and some of the requirements. That's the basic README, but I did say I was going to get into the sort of other production training elements that I've provided in this repo. I think that would be best served in the tutorials that you can find. So the README only has 7, but I added these other 2, the indicator plugins and the back testing. So another feature that I should probably put on the README, but you can plug in your own technical indicators as well, because currently it only looks at price and the kind of time horizon that it has to trade in. So it does come prepackaged with RSI, MACD, Bollinger Bands, and ATR. But if you want to include any others that you would like, or a custom indicator that you want to be put into the environment, you can totally do that. It's pretty simple setup, and this tutorial teaches you how you can do that. It's really just a boilerplate, class that you can create. So this one is rate of change here. You just need end features and a compute section along with the name, but this will pretty much give you exactly what you need. You just need to know the logic, the number of features that it will provide in the environment, to observe, and then go plug and play. Again, we just have the boilerplate here for you, and then it tells you exactly how you can put the indicators into the environment so that you can test it on. Cool. Starting with the first one, right? Like what the main thing I wanted to make sure that this environment could do was avoid overfitting, avoid regime blindness. So you don't even tell it it's in a bull or bear market. It just is able to generalize and understand which one it is. And then really having no statistical diversity is the real killer, in my opinion, for reinforcement learning when it comes to trading. So this will generate realistic diversity that are, that carry the same statistical characteristics of a real market for the most part. I've done my best. I'm sure there are gaps, but it's at a point now where I feel like it's ready for release and ready to get some feedback on. So in the first tutorial, essentially what we're trying to do here is we'll run 10 million episodes where the regimes are switching, and we are trying to train for an agent that is able to be able to find or extract a trading strategy for the market characteristics that we give. In this example, we don't actually extract from a real world equity. We just set the volatility, the drift, the Garch alpha and beta, and then the jump intensity average deviation there. And this will just plot 50 unique episodes of that market condition that we want to set. I had some help with AI, fitting my sort of broken thought processes and poor writing into something that's concise and easily readable here. Well, this is just some more plotting, and then it gives you a link to the next tutorial. So the idea is to show you that we can do infinite data, and then the next step is to convince you of how this is actually market realistic, not just theoretical. And if you were to just do this same thing under geometric Brownian motion, you would lose a lot of the real world market characteristics. So you would lose out on the volatility clustering. You'd lose out on the serial correlation, which is just that AR1 mean reversion momentum, right? The fat tails, like I said, is the distribution at the ends of the distribution curve where you have really small price movement and really large prices within the same period. And then when you have cross asset dependence, so if you have something like Apple and Microsoft in your same portfolio, obviously those things are going to have a really strong correlation with one another versus having something like Apple, which is a technology hardware company, sort of in the world of market discretionary, versus like a utilities company, right? Or maybe you have, a retail discretionary company like, I don't know, Home Depot, right? You have that with your Goldman Sachs portfolio. Like those things likely don't have a correlation as strong as Apple and Microsoft. So you can actually have a market condition that you train your agent on a portfolio that has strong correlation or less correlation, but you're able to put that in there as well. The jump diffusion is just how often do you want sudden crashes and spikes? The idea there is that if you have earnings, you'll be able to get the jump diffusion in a certain way that you'd like. And then this tutorial will just basically go through, screen froze there, basically go through those top level market realistic elements or features of the environment. I'm going to skip ahead to parameter calibration because this is where we basically fit the math that I just showed you in this market realistic tutorial, right? Because how do you actually translate this kind of information into a real training? How do you translate this into actual numbers that you use in your environment parameters? Well, we have a feature for single calibration as well as multi-equity calibration that will extract the information for you. And then it's as simple as just plugging in your parameters into the environment and passing it through. Parallel training is really important. You can spin up multiple environments and it will reduce the training time. So let's see here. This is 7 million steps. 200 steps, so 7 million time steps. That's 7 million divided by 1800 FPS, right? That's about just over an hour. And so you can do that same work with 8 environments times 8 episodes per rollout covering the full regime distribution. So it's great. And you can, you get all of the benefits of parallel environments. Just another nice little tidbit that I threw in there. So you can use that as well. Not much to say on parallel training. Either you've used it before or you haven't. It essentially became necessary for me once you have infinite data and you can run 7 million time steps. You'll obviously want to reduce the time spent sitting around waiting for your thing to finish training. So the extra environments that you're able to spin up, if you've got the hardware to do it, really, really helps out in that instance. But the environment is just one half of reinforcement learning. You've also got to train an actual agent, and you've got to fine tune the policy of that agent to really get into the serious benefits of reinforcement learning. So I've included some things that help with the actual training of the policy and training of the agent. Nothing here is as mind-blowing to me in value as the environment itself, but they're still really important for having good, solid training agents that take it beyond just setting up policy and letting it run 7 million times. So the extractor, I think, is just necessary if you're doing multi-asset, because without it, the environment just spits out, you've got 5 assets and you've got a bunch of prices, and the agent will look at each individual feature as unconnected elements. It won't apply its weights to every single asset. So in other words, it will maybe look at asset 1 and its price movement, and it will calibrate a good trading strategy for that asset. But without the extractor, it will fail to apply those same learnings to that asset, to a different asset. With the extractor, it can share weights, and it will say, okay, I've got 5 assets. I've learned that this particular strategy works for 2 of them. Let me apply it to the 3rd asset. And so it allows to organize the features within the environment to be a lot more structured and allow it to share its weights across the different features. The diagnostic callback is really just helping you understand where your agent could improve. Doesn't just provide you the basic, on this time step, this was your entropy coefficient number, or right. It's providing a little bit more detail about the environment itself. And if we go down there to that specific area, so if you're saying, is the agent trading or is it holding on to cash? Well, we've got a metric for that. Is it, trading a ton in fees? Well, we've got a metric for that. Is it going bankrupt? Meaning, is it just trading to the point where it has no money and then it loses it all? Well, we have a metric for that, right? So we've got additional metrics that allow you to hone in on what levers and knobs you really need to push and pull. And then entropy coefficient is the controlled exploration decay. This is a more advanced training parameter, but if you think about it, it helps your agent balance between exploration and actually trying to get its reward. So if it's too small, it will be scared to explore because it's really worried about having a bad reward number. But that can be bad because then it's not exploring ways for it to actually maximize its reward either. So you need to be able to tell it, it's okay to explore. Your reward isn't going to hurt you early in the game, but then you want to tighten that as it gets along in its training, and it does start extracting alpha. You don't want it to deviate from that strategy too much. You want it to start doubling down on the things that work later on toward the end of your training. And so your entropy coefficient callback helps you control the level of exploration and exploiting that alpha on the reward structure. And then the final thing I will go over before calling it good is the backtesting that we have here. So when you train the agent, we basically put a lot of it into, I'm going to have to work on this a little bit. This is not the best. Excuse me. So the back testing, the way it works is we have a journal that keeps the trades that the agent makes. But, most people, if you're like me, you're not just training this thing to perform well on synthetic data. The idea is that the synthetic data allows you to converge on a policy that allows it to exploit real alpha in the markets. And so if you ever want to deploy this and get an understanding of how it will actually function on historical price movements, then the backtesting is the essential part for you to compare whether or not the training is actually doing what it should be doing. So in many ways, the historical backtesting portion of this is the evaluation of the synthetic data itself, but also whether or not your agent is performing in the way that you think it should be performing. And so this will just help you walk through the synthetic backtest, how to read the synthetic report, your drawdown, your average friction, your Sharp, things like that. And then it walks you through the historical backtest and comparing the two, right? So it's important, but there's certainly a lot I could put into the backtest portion. It was just something that, is probably the least built out, honestly. So there's a lot of room for improvement here, but it does exist, and you can compare the two. Cool. I think that's it. This has been something a long time in the works, and I'm really glad I finally am able to introduce it. Please check it out, and in future videos, I'm actually going to go through beginning to end a training period or a training pipeline, and yeah, we'll go from there. Thanks, and I'll see you in future videos.